about inequalities?
Say it again, please.
Inequalities in specialists, like the
Oh,
graphing them?
inequality. Yes, that's right. Inequality is like something like A larger than B, right?
Yes, but we have to graph them.
Yes, that's right. Good idea. Yes. Yes. Yes, that's right. Talking about yes, that's right. That's right. Can you see? Have you seen this type of question? I just read just calculate. So this is plus 1 and divided by 2x squared plus 3x plus 1, which is larger than 0, something like that.
Mm-hmm.
I saw this. I explained this question to another student on other days. So could you write again any particular example we can start with?
Yeah.
Yeah, inequality, you have to consider both this is just inequality, not absolute value. Inequality, right?
No, it's something like.
Yeah, that's include absolute value. Yes, that's right. Yes. Okay. That's right.
And then we have to graph that.
Yes, you do. You do. Yeah. So what? That is in the context of complex number, right?
Mm-hmm.
Okay. So my example is in a real function. Okay. Now in your case, just make sure this just magnitude, isn't it? For example, if this is a complex number, the first one is 2, right? Is z. There's another one. So this basically they represent the complex number. Can you see 1 is equal to z minus 2 plus I, right?
Yeah.
And equal to what? Z plus 3, right? So another complex number is z plus 3. Yeah. You want to draw the diagram? Okay. Let's try. So if the magnitude, so what is the magnitude? How do we work out the magnitude if you have the complex number? If you use a Cartesian coordinate. So basically we are dealing with a complex number. You say this any complex number z. So you must have the real number, right? And got imaginary number. So that is a coordinate. So the magnitude, so these will be represented the magnitude, right? The R, you can use R to represent the magnitude. So basically we are talking about the two complex number z1 and z2 whose magnitude are equal. And then we need to solve this z. Now in this case, how do we denote the z? We use x, you do use x or y? Do you use this notation?
Yeah.
Okay, let's start from here. How can we work them out? So can we just denote this z? So this z is here, can you see the common z? Do you want to try? So do you know what I mean? Can we just rewrite this as into real and imaginary number? So can we just say, can we do it one by one? Can we start from this one? Can we read this as x1? Well, they are the same z, isn't it? Same z, so must be same x. This must be x plus iy. That is our z, isn't it? The first part, let's just pick up this idea first. Now, can we do some rearrangement so that we can put the real number and the imaginary number together? Do you want to try? We can do the same thing next one. So we just denote this as Z1 and the inside, everything inside, these are Z2. Yes, we can put the imaginary number and real number together. So just remind us, this is our real number, this is our imaginary part, okay? Similarly, can we do something about this Z using this notation? This is general notation. If you have complex numbers, they must have, we can construct the complex number by using real and in imaginary part, X and Y. So this is our X, and this is our Y multiply I here. Can you rewrite this part as well?
Which part?
So this part, so we just use this notation, therefore, this Z is also equal to X plus IY, do you agree? In addition, they got the real part, 3, you see. Can we just put the real part together to see what can we do about this question? Yes, that's the real part. Good, good. So, by the way, if you want to find the absolute, or want to this they call the modular, so I call the you do the modular or amplitude. I call the modular, right? Modular, whatever. It's if you're looking for modular, so that will equal to X squared plus Y squared. Do you agree? Because after all, this is geometry. You can see we are dealing with this triangle, right angle triangle. Now, based on this condition, can we build this this Z and the module, the amplitude, if you like? Can we build these two formula? Can you imagine these are X components, these are Y components? You see? Again, these are X components, these are Y components. This is plus, right? This is a plus. Yes, that's right. Where's X? Where does X go? You have to include all, you see. This is in this case, that question is give you indirectly. You see, this represent X. So you have this X, you can Pythagoras theorem. No I anymore. We are dealing with modulus. Can you see? So this is another equation. So don't get confused. So we want to get rid of. There's no I. Oh, hang on. Yeah, we have to be careful.
If we get rid of I, then it'll be -1.
Yeah, should I? Yeah, let's just I just pick up my thought. Do we have to include I when we do the module?
No, I don't think so.
Don't think so. Oh, no. Must got real number, right? Got real number here. All right. So you got the equation. Based on the given condition, we can write the equation now. The real. Can you see? So it could be the circle or ellipse. Do you think so?
Yeah.
Maybe yeah, actually we can yeah, there are more than one method, but before that, can we solve this equation to see what is a trace, what is dependence of X and Y? Just reminder, just yeah. Can you equal them to do something about it? Because these are equal, can you see? According to the original conditions, they are equal. Yeah, you need to expand that to see you can simplify that. Just see if that one moment. Yeah, you can cancel that. They probably give you a. It's quadratic, right? It looks like it's a circle. It's a circle. Looks like a circle. Can you simplify this? Good. What's a linear equation now? Oh, that's good. It's a linear equation. Oh, yes, a linear equation. That's interesting.
So how would we sketch this?
Well, there's a certainly dependence between y and x, right? So if we divide it by 2, you divide, we got y, we got linear equation equal to negative 5x minus 3, right? It looks like is this linear equation if that condition is satisfied? Negative 5, so something like this. So what's graphically? So you are looking for the graph, right? You want to draw the graph, right? So this is negative. This is something here. What does that mean? Maybe if so x and y satisfy this condition. Perhaps we can. This is algebraical way. Let's just consider another approach. Let's just say if this is complex number. Yeah, have to think about twice. Again, can we just return to this complex number? So if we just assume this, if we just consider this hypothetical z is in a complex number, but we don't know what is x and y is. So they must have some special pair of x and y. That makes sense, right? Oh, yes, that's right. To satisfy this condition, I'm trying to interpret it now. So so x and y must follow this linear equation. Can you see? For example, in this case, the slope is negative 5, okay? And this, can we just redraw that? So this is 5, well, that is a negative 5. That's it. I just do this graph. Yeah, I think that is the solution we have. As long as z and x, y satisfy this condition, we should be able to work out this z. Z is not a single value. Can you see? Z is not a single value. Can we count the intercept first? When x equal to 0, y equal to negative 3. Do you agree? 1, 2, 3. So this is a negative 3i, should I say? Can you see? We just use this, consider this coordinate. And when y equal to 0, what is x? So when y equal to 0, 5x is equal to 3. 5x equal to negative 3, right? So x is equal to negative number. So we just draw this straight line first. So this is a negative 3 over 5. Okay. So it's less than 1, isn't it? Less than 1. And to be exact, what is can you give 0.6, right? 0.6. So when y equal to 0, x equal to negative 0.6. Can you see this negative 1 here?
Yeah.
So that would be very close to this point. Yes, that our green light it makes sense. Can you see? Can we draw this again? So basically that is this time makes more precise. That is a straight line. Aha, in this case, any z, I know what you are talking about now. Any z on this straight line any number on this straight line, can you see, or here, can you see? And whose x and y satisfy this straight line, then that equation, this equation is valid. You see?
Yeah.
This could be z, which is x and y, and x, y are not free. X, y are dependent to each other. Does that make sense? So in other words, you are dealing with all the x of any x, y pairs on this straight line. Does that make sense?
Yeah.
Or in addition, I think we have to do something about this. If this z here, let's just check, okay? Let's just check. If we just check z, can we just check something? Can we just check, use this diagram? So this -1, this +1, 2, 3, this is 1i, this is 2i, this is 3i. Let's just use this graph to see if this work, okay? If we just choose any z, can we choose any z? Can we just choose this particular z here? Oh, this diagram is not very accurate. Should I do it slightly different? Can I improve that a little bit? So this slope is not accurate. Should be -3, right? Should be -3. Let's fix this. Yeah, because we are going to use this graphical method to check if our result makes sense. Does our make sense? All right. I will draw this straight line again. Give me a few moments. So this time I will draw it very carefully. So z -3. Oh, that's much better. Can you see? So let's just do this if that the argument makes sense. Can we start from this point? This point is what? This is this particular value is just a -3i. Can you see? And we start from z equal to -3i. Okay. So just so -3i. So basically -3i. So basically, if this is any z, this could be z3. Can you see? This is not the value. So if we just use this equation, so what is z3 plus 3? What is z3 plus +3, real 3? That will just equal to a new complex number. It's called 3 -3i. Can you see? So we just pick up this one. In the meantime, we use our argument here. We can also build another complex number by use this 3, these 3, can you see? By -2 plus I, right? We just see if they satisfy this condition. So if we put them together, that will be can we put -2 here, right? -2 purely this oh sorry, I write down this first. It's not the same. So this is it's can we get 3i negative, right? And that is our original z, these 3. We start from this special value, and that next then we got a -2 and plus positive I, can you see? So when them arrange them into so that's the imaginary this how to say the real part is -2, and if combine this with -2 I, right? Wow, this is not equal, right?
Yeah.
Are this so something wrong with our? See, this is 3 and 3. Can you see? This is -2 to -2. Where are they? Let's just check that. Where are these value keys? We got -2. We got -2, -2. So -2, -2. This is -2. Let's just use different color. Yeah, that's interesting. Not consistent. We got this one, -2, -2, right? So these are So this negative 2 here, and they got a positive 3, positive and negative 3. Well, it doesn't make sense. No. You see, I'm trying to. This
Yeah.
graph doesn't make sense, right?
Mm-hmm.
Oh, can this is magnitude, right? They just this constrains magnitude. There's nothing wrong. We use this. Can we just double check that? We just denote this this z as x plus iy minus 2 plus I. Double check that x minus 2 and y plus 1i. Yes, we got the modulus. This is one. Extend that, we get a linear equation. And the second one is z3. That would be x plus 3 squared minus plus or minus? Huh? Plus. How did you change the sign here? Is this plus, right?
Yeah.
I think this should be this. I think this should be plus, isn't it? Because we are calculating the module. Module is a real number. Did you use I square? Did you use I square? Yeah, I think so. We don't have to use I square. This will double check.
I just made up that number though. This one.
Because we are looking for x and dependence between x and y, isn't it?
Yeah, I just wanted to learn how to graph these, not like.
Not yeah.
So it's just.
Yes, because
it's just made up. It doesn't match up.
That's right. So I just wondering if you just use the plus to see what graphs can we get. Can we just plus? Can this is plus? Can you see?
Mm-hmm.
If this is plus, this is still plus. This is this will be minus, right? There will be minus. There will be minus. Do you agree?
Mm-hmm.
And this part is a plus, is pretty plus. So we still can cancel y. Do you agree? We can cancel y, we can cancel x. Do you agree? The linear function will be different. Can we just double check that? So this x is x squared cancelled, x squared y can negative y cancelled. We got how can we get oh, you combine them. So this is positive, it goes to negative 10, yes. And then we got negative 1 here, yeah. Yeah, we shouldn't consider. Can we just rearrange this first? I think we should get something equivalent. I know you are trying to draw that picture. Because this is if you just start from anywhere, can you see? And basically we have to use this equation, which is the magnitude are the same. Just a moment, because we have a sign problem here. We have sign. This is certainly not. It's not. It should be only slightly different. Okay. Double check this first. Can we get something? Yes, we should be able to get a dependence between x and y. So this is negative 4x. This side is okay. So this is oh, this should be 4, isn't it? This should be 4, right? Can you see that? This is 2 squared, right? 2 squared should be 4. I just want to make sure we got the correct result first. Y cancelled, and you got negative 2y. And the minus 1. Gosh. Oh. Let's just check that. That makes sense. Okay, let's just spend a few minutes here. X squared minus 4x plus 4 first term plus y square, yes, plus y square plus 2y plus 1 equal to x squared minus 6 plus 9 and plus y squared. So this is plus, this should be, oh, hang on. This is plus, isn't it? Oh, be very careful. This is, yeah, make the signs correct. Otherwise, this straight line is meaningless, all right? If we got the wrong equation, this green line is meaningless. So let's just simplify. Cancel x squared, cancel y squared, and put x together. So we put this, there is a number here. So the negative 10x, okay? And this is a 4 plus 1 is 5, 5 take 9. Can you help me to fill this, to solve this correctly? Can we make sure we double check we got something accurate? We have canceled this here, yeah. We still have, where is the y? Yeah, we still have y. Yeah, we got one y here. It's 10x, yes.
Negative 10. Oh, depends. Yeah.
Yes, because I found so many sign problems, so we have to be careful. So what is the relation between x and y? And how can we draw that straight line? I need to draw the straight line which is meaningful and accurate. Back to the question we obtained, or slightly different. The same equation, isn't it?
Slightly different.
We got 2y, we got 10x, and we got 5. Oh, that is integer. Oh, not much better. No fraction. Oh, yes. It's different. Yes, it is different. Can we, this time we just make sense. Can we divide it by 2?
Yeah.
5x. Oh, it's probably, this is the slope is positive now. Can you see? 2. Okay. Okay, now can we just return to this? This time we need to draw this diagram. We know this now. So this, let's just do this time very accurately. So we just do this diagram. So this is algebraical way, okay? Now we'll check that by using this complex number. But before that, can we draw this simple straight line? What is the x-intercept? What is the y-intercept? Positive 2, right? And do it 1, 2. So this is 1, 3, 4. This is 4, 2. So this is 1, 2, 3, 4. So what is y all have to go to negative is negative 1. Negative 2. So what is x-intercept? 0.5. Yeah, 0.5. So x equal to negative, right? Negative 2 divided by 5. 2 divided by 5 is 0.4, right? Negative 0.4, negative 0.4. Let me see. Wow, that is very close to the negative 4 over here. Oh, so this time the straight line should go that way. Okay. That should be the straight line. Again, we just use this check hub. We just start from, we just check if we can choose.
It should be -2, not +2.
Wow. Oh, yes. Oh, we got a mistake twice, so we got wrong. We get correct, right?
Mm-hmm.
If that is a negative, when x equal to 0 shall be positive. Oh, no. Is this your final result? This is our final result, do you agree?
Yeah.
So when y equal to 0, what is x? You tell me. What is x? From this final equation.
Oh, it's still 0. It's 0.5.
Positive?
Yes.
Well, in that, if that's positive, then you should get the slope is our slope is positive, isn't it?
Mm-hmm.
If the slope is positive, this would be correct. Can you see the positive? When y, what is y-intercept? Y is negative. Hang on. Oh, this can write in here. Can we find this? Let me see. We are using the wrong equation to draw this one. So we can't expect it's correct. Now, can we draw this? Can you draw this equation on this Cartesian coordinate 1, 2, 1, -2, right? So y-intercept is -2. So this -2 here, right? And this 1 here is a positive 0.4, right? It will be here.
Mm-hmm.
This question is a little bit, yeah, that is correct drawing. Can you see?
Mm-hmm.
Okay, this time we start from, again, we just pick up particular z. Can you see? Can we put a particular z here? This z3 is equal to, in principle, any z on this straight line should be satisfied this condition, but we will see, all right?
Mm-hmm.
If that is z3 is equal to just the real number, the imaginary number, -2i, then we work out another new complex, which is z3 plus 3, right?
Mm-hmm.
That will give us, because we got just added the 3, sorry, we just added the real number here, that's 2i. So this is just 1, can you see? So we use this formula to construct this z plus 3 by picking up one of the z on our straight line, okay? On the other hand, we can also build another complex number by using this particular 3 by -3 and plus I, can you see?
Mm-hmm.
Oh, we can't get our what a result, a positive 3. So in this case, what we obtained? These 3 have no real number, so that is -2 for the real number. And the imaginary part, what is the imaginary part? -2, 3, can you see? Oh, that is correct. Yeah, I think because this is the number is different, but the according to, I can see they are same now because this is the length is the same. This should be 3i. Do you agree?
Mm-hmm.
So these two numbers, so these two new complex whose amplitude must be the same, isn't it?
Mm-hmm.
Because why? Because 3 square plus 2 square, or we can use -2, doesn't matter. We can use -2 the same, so -2 square must equal to the same. Can you see these two numbers, they constructed, satisfy this condition. In other words, we have assumed that any complex number on this straight line, can you see? So this is this z is equal to let's just write down. So this z equal to x. Can you see? And we can use y as well if you like. So we y equal to x. Okay. Can we just give you the so any z? Can you see any? Or we can go higher. So any z here, whose formula is x plus and 5x minus 2y. Can you see the I? Can you see? So that is any complex number here will satisfy this condition here. Do you agree?
Yeah.
You see, this is with the reason we spend a lot of time here because we didn't get the correct solution first. And that means that is a solution. So basically, I tell you what is what they imply from this equation, complex number, they need to find what is x and what is y. You see, they need to find the dependence of x and y. Okay. Sometimes this equation give you unique pair of x and y. Okay. Sometimes give unique pair of y, but in others, as we saw here, we get the dependent x and y. So y is equal to 5x minus 2. Can you see? So that's it. So basically, this graph, and alternatively, you can see that sometimes they use a circle to work out this relation, because this no, not this time. Anyway, can you check their answer to see if this is the right answer, please?
I don't actually have an answer. I just made it up.
Wow, you made it up. Oh, well, in that case, well, we you see, can we just pick up another question of same time, but this time please pick up from textbook so we can double check. So why did you choose this type of question? Did you see similar question before?
Yeah, I wanted to learn how to sketch it.
Yes, that's why it's can we just can we simplify this question like this? Can we just simplify this question as this? Can you see? Can you solve this question? Let's just put it just again. I make up this one. Can you solve this one? Can you draw the rather? Can you draw this graph? So this is our second question. Okay, you make a one. I this time I make one simpler. Can you solve this one? So do you remember our strategy?
Yeah. So
we first of all, we just rewrite z as xy. That's our z. Okay, that's our z. Are they equal? No. They say no. Hang on. They only say the amplitude is same. We cannot just rewrite our condition. So when you see this, vertical line, this called sometimes called module, sometimes called amplitude. Yeah. That's right. So how do we work out the relation between x and y? Yeah, don't include y, don't include I, we're in trouble. If you include I, we're in trouble. It's quadratic. The circle. Can you see this circle equation? Can you see this time is not a straight line, this time is a circle with a center somewhere. This is equation of circle. How can we, where is the center of this circle?
The x minus 2.
No, you have, yeah, that's right. Yes, right not. Can we just rewrite that? Can we just work kind of fact? Can you find this equation of circle in general is x take a square plus y square is equal to r square. So that is a circle equation. Or in general, you can also say y is y take b. Okay, equal to r square. Where the center is at a and b. You see?
Yeah.
That is the center. This is the center. Can you just simply can you rewrite our result in the form of the circle equation? So then we can draw the diagram. That is the objective, right? Yes. That's right. Now can you draw the graph? Can you draw this on the in the XYZ plane? It's a circle. Yeah, it's perfect circle. You can use a straight line. You can use a straight line to draw that. Got a straight line? Have we found a straight line? Yeah. So can we find the center first? 2, 0. Yeah. That is the center, isn't it? That would be the center. What is the radius? What is the radius?
Square root of 3.
Yeah, 1.4 roughly. Can you see? So R is alpha is exactly equal to, yeah, in this case, R is root 3, 1.7, sorry. Very close to 1.7. Can we draw a circle with this is 1? I help you for you. I do that for you. Can we draw the circle whose radius is 1.7? You see? 1.7. Can you make it larger? Oh, that's very close now. So 0.3. Right. So this time, this implies a circle. Can you see?
Yeah.
So what does that mean? Any complex number, can you see? This is you can pick up any point on this circle. It will satisfy this condition. Can you see? So that is z is equal to x plus iy. Okay, and we can check that if you wish. So this is a real number, this is imaginary number, right? So this is 1. That's be I. That be 2i, and so on. So basically, if you this is origin here. So that is this complex number is here, and you plus well, that is solution, isn't it? Right? That is solution in the circle. So, in general, the equation of whenever you see this equation, they always imply a graph, a circle, a curve in the complex plane. Do you agree? Whenever you see this type of equation, they imply a trajectory, if you wish, or dependence between the x and the y. So that's in this time, this equation is their dependence. Can you see? Okay, it's your turn. Perhaps you can choose another one from your textbook. Can you show me your textbook?
Yeah.
Yes, I will stop this because it's easier to use your textbook example first. Stop sharing. Okay, let's see that particular chapter. Ah, yes. Can we stop here? Yes. So this first example is using the same strategy we used. Can you see?
Mm-hmm.
Oh, they call the modular. Yeah, they call no, the amplitude is for vector. For complex number, the R is called the modulus. Okay, so that is quasism. This time got a linear equation. Can you see? Oh, this is similar to your example, isn't it?
Yeah.
Okay, we are on the right track now. Do you agree?
Mm-hmm.
Okay, so that is how to use this the square Pythagoras rule to solve this puzzle. Can you see?
Mm-hmm.
And can you find another question? How about this one? This is what can we look at the number 5? Sketch is a graph and intercept as a result. Yeah, to interpret the result. Why did you put an additional 2 point? What is the point? Do you understand?
Mm-hmm.
They put z1 equal to -3. Why did they add this 2 point here, 3 point here? Did they check that? Oh, they check that. Do you agree?
Yeah.
So what is the point? Can we just have a look here? Can you see that caption? The linear equation is perpendicular to bisector tangent joined to the point P. Is it part of the question or not? Sketch the neckers satisfy the condition and describe it geometrically. I can't follow this. Why did they, can you tell me why did they put these 3 points here? One is on the straight, one is on 2R on the straight line perpendicular to this straight line.
This is the original point. Z1 is this one.
Yes, on the left hand side, right?
Mm-hmm.
Okay, and 4 minus I is on the left hand side, right?
Yeah, on the right hand side.
On the right hand side. Oh, yes. But why did they have to? Because I think the objective just found is a straight line, isn't it?
Yeah. They just had to describe it, I think.
Yes, it probably means something. Never mind, we got his answer. Can we go to another example or exercise we can try? Oh yeah, that is same. That's some example. Yeah, in this case, that implied area. Okay, that's interesting. Yes, that's inequality. Do you agree? At the beginning today, you say let's talk about the inequality, right?
Mm-hmm.
But I thought you are dealing with a general real function equality, but actually, you are talking about equality in the context of complex number, right?
Mm-hmm.
So obviously, because if you just consider complex number whose radius, okay, or whose modulus is a radius of the circle, then you can graphically interpret this or represent this inequality as this area in the circle. That means that any complex number landed in this within this circle can satisfy this condition.
Mm-hmm.
Okay. And again, this is just part of that. So if the real part is larger than 1, then that would be the area like this, right? Any area on the right hand side of this vertical x equal to 1. Can you see?
Mm-hmm.
Can we go to something combination? Can we go next one? This is a combination, 2 constraints. They have 2 constraints or
Mm-hmm.
State region because if both the equation must be satisfied, then you can see the consequences. This is if you like, if this domain or range change, you see, domain or range change.
Mm-hmm.
So this third diagram is a combination of the two constraints. You see, number one, Z must be satisfied that they are in this circle centered at origin, right?
Mm-hmm.
Two, the real part must be larger than one. When you combine these two constraints, then we ended with this the third diagram. Okay. Oh, you ask a question if you have any question. If you understand, we can go to another exercise. Sketch, yeah, the sketch. The first one is simple, right? The real part is equal to 2. So that when you say equal, not inequality sign, you know this time is just a straight line, vertical straight line, isn't it?
Mm-hmm.
It just can you this first one? Do you know how to? And also the second, can you draw this too? Just get familiar with this idea first.
So for the straight line, you have to have real Z.
Yeah, they just say that they also get familiar with the notation. Real bracket Z, which means the real part of a complex number.
Mm-hmm.
In bracket Z means that is the number the number of the how many I. So in this case, the number in front of I is -3. This is simple now. Can you see? Can you go to something challenging? Aha, can you see? I would start from this type of question, which give us we know that it's actually imply a circle. Can you see?
Mm-hmm.
That is the second question I make up. Can you see? Made up today is a circle, right? There another notation here that is angle. They call the argand, right? Argand,
Mm-hmm.
ARG. That means angle. They just they just notation for that angle when they use the polar coordinate. Yeah, any question? Particular question?
No, not really.
So you can, yeah, see next time you probably will show me the chapter names, all right? So that you can help me to focus on that particular topic quickly. Because at the beginning I thought you are dealing with inequality in general. So when we're dealing, for example, that's why I'll ask you. Oh, by the way, can you stop your sign? This is also relevant. Just remind you, this is also this is real complex. Let's go to next page. And this also have you seen this? Have you solved this type of question? So this is real number. So that's x squared minus 2, and that is larger than 5. Have you solved this type of equation? This time x is real, so x is real. So today at the beginning, I thought you are going to ask me this type of question. Do you know how to solve this type of question?
Yes, I think.
Yeah, how?
Do you just? Oh, actually, I don't remember.
How do we remove this inequality sign? Sorry, this is called absolute. Can you see? This is different context. It's called absolute. So this sign called absolute. Absolute
I'm
value.
not sure.
Yeah. So absolute value means is constant, which is so basically that is they have depending on what x is. Can you see? This part is 2. Can we just go to the linear part? Can x minus 2, right? This is example 1. This a simple one is example 2. Okay.
Mm-hmm.
So you have this one, then you can rewrite this into two equations, you see. One is x minus 2 is larger than 5, can you see?
Yeah.
And another is x minus 2 is smaller than 1 if x is negative. You have checked that, all right? So you can rewrite this, unlike the complex number, we use the Pythagoras theorem, right? But when you're doing this kind of inequality, you have to rewrite that amplitude into two equations. So if I just go to some simpler, how about x amplitude 6 equals larger than 5? So what does that mean? If you just follow this idea, so this is a real number. This is just our x-axis, right? So this is arrow. So this is our x. Can you see?
Mm-hmm.
So this is just a real number. So this time is just a real. In this case, if you see this constraint, which means that this range would be x if x is larger than 1. So basically, we can rewrite this as two equations. One is x larger than 5 if x is positive, can you see?
Mm-hmm.
Is positive. However, we have also incorporated other condition, which is when it's negative x, can you see?
Yeah.
You see? So in this case, then we have to write x larger than 5. Larger 5. This 5 is sorry. We have to change the sign here. So we have considered this case. So x much is smaller than 5. If x is negative number. Does that make sense?
Mm-hmm.
So this called is absolute value of x. Can you see the absolute value of x? So if you go to example, say we have just we got to use a number. Can you see? This time we just use number. So if you say what is 5? What is say if this is negative 2, this is a positive. This is 0. This negative positive 2. Positive 2, just 2. All right. These are numbers axis. If say this is absolute value, so if something absolute value is larger than same question. Sorry, this is the same question. So this is if we got we can change to twist the question. How about less than 2? So the absolute value of x is less than 2. This time would be this region. Can you see?
Mm-hmm.
Or depending on which is equal or not. Can you see? Sometimes you got this. If I put it equal, then we can this is empty case. This is not equal to. This have to use this notation. Can you see that? So any value, positive or negative, doesn't matter. Their amplitude, for example, in this case, negative point, negative 1.4, for example. Does that satisfy this condition? So what is the absolute value of negative? What is negative? What is absolute value of negative 1.4?
1.4.
Yes, that's positive. So this is always positive. So, but when you're dealing with this one, you have to learn how to rewrite it, how to remove the absolute sign. Okay.
Mm-hmm.
At the beginning, I thought you asked me this question.
Yeah.
But also, it's a part of your specialist question. All right.
Yeah. I think that was year 11.
Yes, that's year 11. I remember. Yes.
Mm-hmm.
All right. We'll stop it here today.
Yeah.
Okay, take a break, holiday.
Mm-hmm. I'll see you when school starts again.
Okay, you contact me. Thank you.
Okay, thank you.
You're
Bye.
welcome. Goodbye. I will save that.